All right, guys, welcome back. This is going to be the third video in the series. This is where we're going to start kicking off at a much more professional level for what I think is a great introduction to EFI. Um, we're going to cover some of the fundamentals of what is going on in an engine. What does this mean as far as like comparing mechanical information to digital data? And gonna have Claudio kick it off with he's got a beautifully written list here as far as a I don't know, it's a nice index of going through the right way of starting. And this could be if you have a base map that you're starting yourself, or if you don't have a base map at all, or if you are just trying to diagnose something for your car. We're going to get there eventually, and then eventually we'll go even further, get into advanced stuff that no one else seems to cover. So, Claudio, go ahead and kick it off, buddy.
All right, man, thanks. So what we're going to do today in this first part of it is going to cover some of the basics that we think is, first of all, first and foremost, the order of operation is critical. A lot of phone calls for tech support that I've held over the years always start with people cranking and cranking and cranking on their engines, and they just can't get it fired up. And what they're doing is eventually fouling plugs, flooding the motor, creating hydrolock, which can create other potential problems. So, what you need to know, our first point will be what you need to know when starting your standalone ACU installation. So, from there, the general thing to consider is wiring. How is the ECU wired up? What to tackle first? Eventually, like we said initially, the order of operation is critical. A lot of people just start connecting absolutely everything. They plug the ECU in, there's no map loaded, and that causes trouble. So, recommended installation order as far as what to wire first, what to check first, and how to continue with there. So, general wiring practices as far as your gauges, as far as grounding, as far as power requirements. Certain coils need more thicker gauge wire than others. Where you locate your battery is some of the most critical points to consider. And lastly, on this first section, we're going to talk about a good complement of basic tools to have, not just wrenches and socket wrenches and torque wrenches or whatever, but a good understanding of a voltmeter, a logic probe or an LED test light. An oscilloscope is one of the nicest to have tools, but thankfully, a lot of the ECU manufacturers are putting it inside the software now, which is fantastic. And of course, what all the installation requires as far as where to go and how to tackle everything. Where's your battery located? How much grounding you have? Is it properly done? Is your starter getting a good thick power wire from the battery? Is the alternator connected? Do you know how to connect the alternator? Do you know how to build that? All this stuff can be covered eventually in the wiring section.
That was really, really well done. Yeah, I don't even know where to go from there. That was, geez, Claudio, that was
I mean,
beautiful.
if I were to say, if I were to interview you, then I would say, okay, so where do you start? You're wiring up a car. What do you want to do first? You want to grab a harness, a flying lead harness.
Before I touch a harness, yeah, before I touch a harness, I'm listing out my sensors. I'm going to say, okay, I've got these things that I want in the car. I want to have these features when I go to control the vehicle on a driving standpoint as a driver. Let's say a rolling anti-lag or something that you have an in-cabin switch. And then I divide things out to where, okay, this goes in the engine bay, this goes in the cabin, this goes in the trunk. And once I have my sensors and the locations of certain things, then I can figure out what each of those needs next. That would be that first initial step for me.
Definitely. It's good to know that if you're wiring what happened?
Keep going. This is a battery.
Okay. You want to just pause it? You can't pause it, can
you? Battery
and
life
we're
on
back.
Cameras.
So the Dominican in me goes, power outage?
Oops. Yeah, yeah. The rolling brownouts, because they don't call them black in California.
Ah.
Oh
We
shit.
ca- we call them apagón, which is a
Yeah,
shut off.
shut off. Perfect.
Anyway, so as we were saying, we're basically going over key points as to what components will need to be connected to the ECU, what wiring do those components require, whether it's high quality heat resistant wire or
Shielding.
normal shielding or exactly ground RF, all that stuff. So once you know exactly what your components going to the ECU, then you can plan out locations, wire length, what harness do you use. A lot of people just buy the flying leads from the manufacturer and just wire everything in. There are pros and cons to the manufacturer supplied harnesses. And depending on the level of experience of the user, we can obviously say a few points to consider why it would be ideal versus why not. Now, moving on, we'd say, so what is the uh, main thing that I hear with installation is, oh, I got a trigger issue. I've got noise problem. My engine won't rev past 5,000. That's my favorite one and the most common one you get. It's either 2,000 or 5,000. I don't know why. So yeah, these things can probably be the result of noise in the harness or a poorly set up trigger filtering or configuring of your systems. Um, this is
Personally,
where
oh yeah, go
this
ahead.
is where the yeah this is where the oscilloscope is a great help. And even if you don't know how to use it, either your tuner will be familiar with it, or you can definitely jump on the bandwagon on the internet and try to find a couple of YouTube videos that explains. They're not that hard to do. You just need to tell it how much time do you need to spend watching and how high or low the voltage is going to come in. That's about it. And what channels to look at.
So, from personal experiences, the number one killer for all engines that I can even think of is always crank angle sensor loss. And to me, that's something where if you have access, which you will, because it's not expensive, to go buy a shielded M27500 cable for anything that is noisy. So that'll be your crank angle sensor, your ABS sensors, um, CDI boxes, stuff like that. You will have a very, very high-end shielded bodied cable for the most important sensor on the vehicle, which is your crank angle sensor. Um, the next thing is always going to be grounding. When we have someone who has a tiny little, I'm not going to say brand, tiny battery that's relocated and it's in the trunk, and you've got a little 10 gauge going to the chassis, and you think the chassis is going to ground that car out and going to be the effective ground for the vehicle,
Nope.
you're very sorely wrong.
Yes.
So, so
Always make sure you have the right grounding wire gauge going directly from battery negative all the way to the block.
to
Pick
the
a nice,
block.
yes, block. Pick a nice spot in the middle of it and then think to yourself, start point. Just branch out from there.
Start point being if you had a singular point on this block, everything is coming off of one singular point.
Yeah,
Um,
don't go point to point because that creates a ground loop.
Ground loop.
There's a nice video about that on one of the ECU manufacturers' YouTube channel that we can probably
We can
link in.
link to that. I
Yeah.
did another similar one like that. There's probably 30 good ones out there, to be honest.
Yeah.
If you don't get it by then, just look, say, are my wires all going from a singular point? Can I draw them off from one point? And if they're not, redo it. That is going to cause problems. It's going to create issues that you don't even realize are issues until 9,000 RPM or
Or before you even get started.
before
Hey,
you get started.
my starter is not spinning at the right RPM. It's only doing 100 RPMs. Well, that's probably because it's only going off of the positive. Ground ground side also needs a kick in the butt. Your coils will work better if you've grounded to the block and your block is grounded. You get much nicer spark that way. A lot of noise gets eliminated when you have proper grounding. Obviously, the shielding in the trigger wires is critical. It needs to be properly grounded at the ECU end, not at the engine end. Some people sometimes see the shield ground on the engine side and they put it down to the block. That just creates a big
Worse.
antenna, a big
Yes.
antenna. Yeah. So don't do
So
that.
so we should actually explain that. On a vehicle, we have a multitude of different grounds for modern ECUs. We have what we call a battery or chassis ground. That's going to be like the dirty ground. That's the overall negative terminal of the battery going directly to that. Then we have what would be, let's say for an ignition coil, you're going to have a cylinder head or a rotor ground. That's going to be its individual grounding to that location or that piece of aluminum or iron or whatever it's on for the engine. And you have a third ground, which is going to be all of your sensors. That's going to be a signal ground that is internally regulated at the ECU. Am I right? The signal ground
Correct.
is going to be something that is internally regulated at the
So
ECU. It
never
never,
never use the sensor.
go ahead. All right,
Yeah,
you can,
never use the sensor ground for anything other than supplying the ground for the sensors.
right. So a signal ground is going to be specifically as an internal use only, for it will never touch the chassis. It'll never touch anything else. It is a filtered internal ground for specific sensor usage.
One key point to mention about the sensor ground is that a lot of the ECUs have also a specific dedicated trigger and home or crank and cam sensor ground that are specifically designed to feed the sensors and nothing else. These help filter out even more noise from those signals and should also be only used for that. Couple of examples real quick is the case of the Toyotas where they have a crank signal, two cam signals, and a common ground for all three. Here is the only time where you'd be using the sensor ground for that. Under normal circumstances, when there's an individual ground pin for each sensor, you want to use the individually supplied grounds for the trigger and the home, or the crank and the cam, or the sync and the ref.
What's cool to think of is the progression of modern ECUs has really, you can see a difference of a company that really cares for you on this thing, this subject, and those that are more budget minded. Um, we can think of, I won't say specific names because it just takes away from it, but there are companies that are still using a singular ground, and then it's no signal ground at all, it's direct chassis. Then there are other companies that are doing multiple, like Claudio was saying, specific grounds for these will be for these noisy style sensors, and these have a different filtration internally. These will be for these, and they're more internal. And then you can select them based on the type of sensors connected, and then they go through a different secondary process for filtration. So some companies, when they lay out ECUs and they make these circuit boards, are really pushing reliability from that as a basis.
Definitely. Always look at your pinouts for your ECUs, analyze exactly what needs to be connected, and you will most likely see, oh, look, this pin is a ground for the crank sensor. This pin is a ground for the cam sensor. This pin is a ground for the rest of the sensors. And then that's where you know exactly how to wire it up. One of the other things that we would like to talk about is basically the installation order. In my personal experience, and this is just me doing what I've done for a lot of years, is don't wire absolutely any outputs. No coils, no injectors, no solenoids. Only concentrate on your crank and cam sensor. Wire them accordingly. Lay out the wires as they should. Don't get close to the alternator or the coils. Make sure you run them nice and neat. And then give the engine a crank. See how it's spinning. You should be able to diagnose with your ECU how fast, because it's reading RPM, or if it's not. And if the ECU itself is understanding that crank and cam signal so that it knows exactly what you've told it the engine is it's firing. So if it's a Toyota with 12 teeth or 32, if it's a Volkswagen engine with 60 minus 2, or if it's a Subaru with 36 minus 2 minus 2 minus 2. There'll be a little bit more technical discussions later about crank and cam, but that way the ECU will give you messages saying, yes, I'm understanding both signals. I should be able to fire exactly when I need to. Then the next step will be to properly dial in, sync the ECU with the base timing of the engine, so that both the ECU and the engine do the same thing.
So one thing that's kind of cool with that, Claudio's method is similar to if you go to build a computer, actually. Okay, so when you go to build a computer, you're always going to be dry testing that motherboard before everything else attached. You're going to have the CPU, the motherboard, standalone. You have maybe one stick of RAM, no video card, nothing crazy. And his basis that he's explaining here is the same mentality. Keep it simple to start with if you're doing a basic harness yourself. Make sure you're starting off with nothing to overly complicate it before you get the basics and the fundamentals down. It's a really amazing piece of advice.
Yeah, essentially the reasoning behind it is, and this is like, it goes back to forever. If the ECU sees proper crank and cam and it syncs and it's telling you, yes, I see them perfectly, and there are a lot of ECUs that have a message that says, I've got full sync.
Full sync.
It doesn't matter what you do. You hook up coil number 1 and the timing should be there. You hook up the rest of the coils, which is the next step in the equation. Don't worry about sensors. We're making sure that the crank and cam work and that it's firing correctly on all cylinders. You can throw ether at this. You can throw booze at it, alcohol, whatever. Funny story. There's a Start Ya Bastard from Australia. It's basically just carb cleaner relabeled. You can throw that in there and it should fire up. It should go boom and just give you some sense of direction. And then, of course, the next step in the equation is to hook up your sensors, because now you know that you've taken care of the crank and cam. The ECU is going to fire the coils right. Now it needs to know what else to do properly. And by that I mean it needs to be monitoring sensors to make decisions on how to fire everything else. So the next step in the chain is wire your sensors. TPS, coolant temp, air temp, wideband ideally, and then these are just the basics. You'd want fuel pressure, oil pressure.
Oil pressure. Oil
fuel.
Pressure saves motors.
Fuel.
Yeah.
You can do, that's a good subject for later on. We're going to talk about why the fuel pressure sensor in the tuning is key to keeping a happy engine, even if all else is kind of falling out of spec and out of whack. Especially if you have either crummy injectors or a dying fuel pump. But that's a different subject.
We can jump in that really short, and I'll just say
little preview.
Modern ECUs, unlike previous generations, if you have a fuel pressure sensor, something starts to get clogged, you have a differential pressure change from that is
or not even previously. Not even a clog. It could be as simple as the injectors are just not flowing the same, and your wideband sensor saying, hey, something's going on over here. And then the ECU says, well, my pressure's good, my differential's great, but the reading over here isn't right. What's going on?
So what it will do is it will compensate your fuel map for you to a given point on almost all of these mappings, because for speed density, it's part of a calculation. And you'll have, because the fuel sensor is now showing a different pressure, it will now compensate the injector accordingly. If, of course, you start with your basics of setting up your injector data properly, which we'll go over as well.
We will definitely go over setting up proper injectors. And basically what the key point to take away in this little bit is there are ECUs that regrettably just either are too old or not updated anymore, that just don't have the safeties, don't have the compensations, were not designed with the advanced features of today's ECUs. I mean, I could give one example. I was tuning a car and we had a massive pressure drop, relentlessly just bombard us all the time. The car would go up to 67 pounds of pressure and it would drop to 34. at over 20 pounds of boost. And no matter what we did, we went over the fuel system, the line, the placement of components, everything. Nothing worked. In the end, it turned out that the pumps we were using did not cut it. We switched pumps to a different brand. Problem went away immediately. The key thing here is that the ECU was so well dialed in that it did not let the car go lean at all. Pressure just got so bad that it went into safety and protected the motor. But we were able to push it into the 20+ pound range, and it would rock solid AFRs.
Yep.
Yeah,
There's so many cool things that these modern ECUs have. And we'll try to go over at least our favorite features and then things that always come out as far as on the tuning side that we've experienced, to make sure that you guys can kind of, I guess, future-proof is the right term, right? Future-proof your setups to make sure that there is less drama in your life. You get to just turn the key and go enjoy driving. Like that's what I think we're all loving of this. I know the design side of it's really fun, but being able to have the adventure of taking your car out cross country and not have to worry about it for that just seems like a way to go to me. So
I mean, it's simple. It's really simple. An ECU, an advanced ECU, costs a lot less than an engine.
And
But
the reason why they got advanced is because of the hindsight of all the failed engines. So you think about the expense of this ECU, it's not anything near what it could be.
Yeah, I mean, if you think about it, if a $3,000 ECU, just to put a number out there, saves you a $10,000 or $15,000 or $20,000 engine or even more, there's no reason to shortchange the main thing that's going to keep your expensive engine from blowing up. All right, so moving on. Order of operations. You've got the sensors in there. You've got the coils. It's firing spark. You throw some start you bastard on it, and it goes off. You see it turning and chugging. All right, time to wire those injectors. Time to make sure you've got proper injector data in there. Time to make sure that everything's in the right order, in the right, connected in the right spot. And of course, you've got your wiring, again, power requirements met for the amount of injectors you're using. You're using high impedance injectors, not much to worry about these days. If you do still have some big, fat, heavy, low impedance injectors, like I could think of what do you call it?
The big Moran injectors that you're probably thinking of.
Well, no, those.
Billet atomizer, fuel tech. They all.
Christ Almighty, no. Oh God, the 190 pound, 195 pounds. What are they?
Deca.
No, the Deca. The Siemens. Whatever. Those big Deca. Fat boys that everybody likes. Yeah, the Decas for methanol. Everybody likes. If you got those, you got to take some considerations, both with your ECU's capacity to drive them and the wiring, the power requirements and amperage and draw and all that other stuff, which eventually we'll cover.
A peak and hold driver is usually pretty strong in most ECUs.
Isn't it nice when you don't need an external box?
Why do I need this box this big?
Why do I need this box? What's in the box? Okay, moving on.
My favorite thing is when companies stack all their boxes and they just get hotter and then hotter and then hotter and then hotter. And then you're like, what happened to my computer? It just melted. I don't get it.
Geez, sir. Well, you did get our box. You got another box.
Stack your boxes, friends.
No stack your boxes. One box to do everything.
Right.
Anyway, see, that's an interesting conversation, and that would probably fall into the category of nice to haves versus what an ECU can do on its own versus what it can do with more boxes attached to it. That's a different conversation. So anyway, order of operations. Now that we've got our cranking cam, our basic sensors, our ignition, our injectors, we've actually been able to fire it up and get it to go and idle a little bit and then maybe perhaps shut off because we haven't done anything with the tune yet. Then the next step, of course, is do you have any advanced accessories, solenoids or controls, stuff that you need to hook up? Then this would be the time to do that. And we're talking cam control, boost control, idle control, which probably would be my first thing to do before anything else, because that way the idle can help the engine stabilize and run a little better. Granted, provided the fuel and timing are dialed in correctly first.
Timing light. Timing light
Yes,
being the number one
timing
first
light.
important tool.
Actually, there's a very good note about timing lights. Usually, you want the cheapest, simplest, no electronics, no dial adjustment, just the on-off button, if anything.
Right.
Because sometimes the different circuitry in the timing light can sabotage your reading and you don't get exactly what you should be. Another thing to consider as well is with coil on plugs, you cannot measure before the coil. You have to measure after the boot. So you need an old lead down to the plug, put your timing clamp on there, and that's the right way to do it. There are some like spark plug
The
gaps out there.
testers don't work.
No, okay, well, just
No, no,
get an
no.
old lead.
The adapters you're referring to, the ones that are going before, don't work. So
No,
exactly what
no,
Claudio
no,
said.
not before that. Hang on. Ooh, where is it?
So what he's saying is on the bottom of the boot, from the coil down, those ones work perfectly. When you go to set timing, I've seen this a few times and it really scares me.
Well,
If your
okay,
battery is relocated,
yeah.
okay, you don't need to use the battery positive and negative. You can use the alternator because that's going to have direct battery power. Your negative should be your engine's ground that you've brought up as your start point. If you can't get it there, you can use a strut top. That's probably at least decent ground. And then if you look at the clamp of the time light itself, the clamp is going to have an arrow and the direction is going to the spark plug. It's very important. Also, in the
Sometimes,
spark plug wires, they have to have a
uh,
separation between them. And if there's not a separation, you're going to have crosstalk between the spark plug wires, even if they're spiral wound or doing anything for EMI. So those are very important to have separated at all points throughout the entire run of each spark plug wire. If that's not done, shit gets bad. Go ahead, Claudia.
I've had a few timing lights that are good, but the arrow actually works better the wrong way.
Wrong one.
Yeah, and for some reason you put it the right way, flip it over, perfect.
The guy who was scribing the light that day on the $20 timing light, he was like, "Oh crap." That's how we got fired. That's okay. Not Claudio.
No, I mean it's a bit of a tip. If your timing light is not reading where the arrow needs to be pointed, flip it over. It's still going to work. Anyway,
So what
uh,
you were saying before is very important. So if you have a coil unplugged configuration,
yes.
um, as you're saying
Keep
below,
talking.
yes. So below the spark plug coil, you can add an adapter that goes to your spark plug and clamp it there. The way that I've seen it incorrectly is when you have a spark plug tester and it's doing it on the front side of that coil before it's like on the signal side. Those don't seem to work very well. And you'll normally have a different timing as a result of what do they call that? It's a your millisecond delay is going to be incorrect. But he has an example. He's pulling it out somewhere.
Christ almighty, where the hell is it? Never mind.
Not bad for video 3, guys. We're going to just continue getting better at this, I promise. Don't worry.
I wanted to do a show and tell, but sorry, it's
Show
not
and
here.
tells are fun,
Yeah.
but you know.
Anyway.
So I
Yeah.
think that pretty much covers the initial necessary tools, the installation, keeping things simple, like I was saying, motherboard and CPU only with your, crank angle sensor and basic harness starting.
A little bit of a tip in the cranking cam department is, hey, I don't know what sensors are on my engine. I can't look because the thing is inside the block or in the head, and I don't have any tools to pop it open. Well, hey, your ECU has a oscilloscope built in.
Yeah.
Hook them up, and then try to see if you got a signal. If you got a signal, then it's a starting point. There's two things that can happen. You can see a signal, but the ECU doesn't react, or you don't see a signal, and either the sensors are not working right, not wired right, or something along those lines. But if you have a signal, then you can immediately just pause the scope trace, and count the number of teeth, and you should be able to determine exactly what your engine has. Most ECUs now have a little wizard or a drop down or a menu that says, well, this engine uses this. And then you should be able, otherwise, just Google is a great tool.
Yep. And there's a falling and rising edge, right? So if you look at this and the direction in which it's going is going to give you a little bit of a head start, wouldn't you say?
Yeah,
So
well,
how you're
we can
reading
go
that.
into
Yeah,
we
yeah,
can
we'll
go
go into
into
details later.
the different types and the different
Yeah.
signals and what to see on the screen and what to expect. As long as the ECU is happy, it'll be able to pulse, control, do its thing, and that's the end of it.
Cool. Anything else you want to add for video number
I,
3? I think
I
that's
think I think that's a good first start to a beautiful thing.
we
We've covered
crushed
the
it.
basics. Yeah, we've got the basics. Just to sum them up real quick. So you need to know what you want out of the setup. You need to know what the capabilities of your ECU is, what you need to plug in, what you need to put in the engine bay, what needs to go in the back, what needs to go near you so you can reach it to activate or whatever. Wiring recommendations for power, ground, and shielding, and so forth. What tools you need to have. So we talked about your voltmeter, your probes, your oscilloscope, your timing light. All these are critical to give you the information the ECU needs to verify in order to work correctly. So on the next one, we'll probably delve in a little more on what exactly you need to watch out for in our order of operation. So we're going to start first with the crank and cam setups, offer a few recommendations on different engines, a few recommendations on different ECUs, and we can continue onward there.
And I was going to say we have a few more minutes, so I just saw that we actually have a timer, thankfully.
Yeah.
So the things we can cover are there's a difference in materials for wiring, and based on your budget, shielding is a big deal for a lot of these things. Um, Wire protectant for specific locations. If your engine has a lot of hot things around it, you're going to have something like a fire sleeve, dragon sleeve, whatever it's called. Um, there's TXL, GXL, which are kind of like the more mid-grade. We've got M22, 759, 16, and 32, which
Dear
is
old
your
Pep cell.
TEF cell.
Okay.
And those are kind of like your higher end stuff. And then what really differentiates between like a entry level harness, a club sport harness, and a mil spec harness, or whatever you go beyond that, if you want to call it auto sport, whatever you prefer. I don't call it mil spec personally, but um, is how things are sealed for their environment that they're in. And that's going to be really basing, do I put 100 hours in this harness? Do I put 10 hours in this harness? Do I put 2 hours in this harness, right? So you have this whole gradient that you can choose from for your needs and how well an object is sealed and prepared for your usage is going to be up to, the needs of the vehicle. And Claudio is amazing to help you and guide you in getting that in.
One thing I would add to this is obviously budget is very important. You could say, well, I have $1,000 for a harness. Okay, then your tuner has two choices. You can either say, well, okay, we've got this harness, which is the universal one that comes with the box. The wire is of A quality. It'll do the job if it's done right, and that'll get you in your budget. Let's say you have a slightly higher budget. You have, let's say, a $2,000 budget for your harness. Well, on that assumption, we can use a slightly better wire, not the top of the line, but it'll be wrapped differently. It'll be shielded better, and it'll be run much nicer, and it'll be wire that actually handles a bit more temperature. Then you have a higher tier. I mean, the wiring budget can be probably unlimited. We can
It
say
gets
that safely.
pricey.
It gets ridiculous very quickly, but the next tier over, let's say tier three, let's say a $3,000 budget. Now we're talking Tefsel wire, which is highly resistant to temperature. It is much better conductive. It can be of a smaller gauge, a smaller jacket, so thinner, lighter, and you wrap it with the best heat shrink money can buy. And then you seal it all up, and it's a harness that'll last forever done right. Some harnesses even survive fires. The connectors not so much, but the harness itself can easily be repaired after that. So, like the ECU, skimping on wire causes a lot of trouble. If you at least have an entry level budget for a harness, which would be good, or you don't have a budget at all and you want to tackle it yourself, we highly recommend that you read up, try to do the harness in the best possible way possible that you can, so that way wires are not running correctly. You don't splice everything with butt connectors or improperly, and then it just causes all manner of chaos and undermines the installation and the setup.
A little bit goes a long way. But this is the best investment to your reliability. So you don't go driving around in hoopty Yanaka $250 coilovers when you have $4,000 wheels and a $80,000 car. That just doesn't make sense, right? So not cheaping out on wiring is going to do a very, very good, I guess, return investment for your build.
Definitely.
And that's why we're going to kind of go through a lot of these things in detail and make sure that you're covered. And then all this makes a little bit more sense for you, to why certain things cost what they do, why certain methods are done the way they're done. And I don't know. I think for the most part, we'll get it all to where it's cohesive and it makes sense for whoever's listening in.
Yeah,
You can
hopefully.
like it.
I mean, the point of this whole video series will be to give the average guy a bit more info so that they can handle a bit more stuff responsibly, and so that their car is just as fun as if they took it to a tuner.
Yeah. Or irresponsibly. I mean,
or yeah, you can always blow it up.
Yeah,
All right.
we'll show you how to do that too. Don't worry.
Yeah, we'll continue on the next module. We'll discuss a little bit more in-depth stuff and more info on cranking cam.
Catch you guys in the next one.